All right, so we're going to begin student handout 3, evaluating expressions. So you should have your packet opened up to that page and everything else on the screen. I'm assuming you have also your Chromebook, headphones, something to write with, and a readiness to learn. So we're going to start the next section right now. Here's the standard that we're going after with this one, okay? If you look right here in the green box, we can write, read, and evaluate expressions in which letters stand for numbers. So we're moving on now from what we've already known, and now we're applying it to new context where we'll start seeing variables in the mix. What's a variable, you ask? Well, we'll get to that. If you look at this progression right here, we should have a good thorough grasp of this by now, exponents, and then the order of operations. And now we're evaluating expressions, which will then lead into just some mathematical properties that we'll discuss in the next lesson, writing expressions, and then applying those to just the real world. So that's where we're going. This is where we are. This is what we still have before the unit is done. When we talk about evaluating expressions, you can see up here in this first box, that means to find the value of. So if you evaluate an expression, you're finding the value of it. So like if we look over here, you can see some problems like this one that you're supposed to solve, and they give you the value of the variable. Like solve this when x equals 4. So you would just substitute that in there and see what you come up when you get 8 times 4. Same thing here. Now it's a division problem, really. 24 divided by x when x equals 3. So they're telling you the values of the variables. That's what makes it possible for us to figure things out and to evaluate them, to solve them, or as they say, to find the value of them. You can see another example down here. Evaluate this problem when w equals 16. Or if you look over here, they might throw some negative numbers in occasionally. Okay, evaluate this expression right here when A equals this, B equals this, and C equals that. So lots of problems have you substitute. We're going to come back to that word, but you're really doing that when you evaluate expressions. Okay, this was not in your notes, but this is just a glimpse of what this looks like sometimes. All right, one thing to keep in mind, this is very important. The order of operations is still something you got to think about, okay? So remember these steps right here, the parentheses first, exponents next, then multiplication or division, and lastly addition or subtraction. These steps we will still follow when we're solving these expressions. So you have to kind of keep these in mind at all times. And you want to remember that sentence if it helps. Please excuse my dear Aunt Sally. That should be a reminder of what you should look for first and second and third and so on. Because again, we have the order of operations because we all want to get the same answer to that problem. All right, so if we start with what you're looking at first, it says right here, use the key below to complete the joke. You see some shapes here and you see a key down here. What I want you to do is pause and figure this out first and see what you can come up with. So go ahead and pause. All right, so here's what you should have found. What's the king of the pencil box? The ruler. Now, math joke, haha, funny, funny, funny. But you know you kind of got that by plugging in these values when you saw that shape. So the triangle upside down was a T, so wherever you saw that, that's where you plugged in a T. And the same for the square and the circle. But we basically substituted these values in there to make it happen. Now, this can also be true with math problems. Like if you look down here now replace the following math messages and evaluate them. Well, if I see that that's a triangle, then that's really a 24 according to the key. And then that's really going to be an 8 right there. And that will really be the square, which has a value of 4. So once I substitute those, now I can solve this problem. And I would realize that this right here is really 3. 24 divided by 8 is 3. So essentially, this is 3 plus 4, which we know to be 7. You should fill that in right now if you haven't yet done so. If we look over here at this one, again, plug in your numbers. Oh, not that. Plug in your numbers. So like I could say that this is the 24 now, minus, well, the circle we said was 8, so there'd be an 8 right there. and then the square was 4. The only thing I don't like is that my circle has covered up the parentheses. So let's make it so that we still see the parentheses. So now it's 24 minus the sum of these two numbers. And again, we start with parentheses. So that's really 12. So 24 minus 12, well, you know that answer. That will also equal 12. So you should write that answer in there right now after filling those in. Again, if you need to pause, please do so, but fill those in. All right, so when evaluating expressions, this is something we got to keep in mind. When a letter stands in the place of a number, it's called a variable. This is not new to you. We've used variables a lot this year with our visual patterns, but it's basically a letter that represents a number. Okay, a variable represents a specific number in each expression. So they stand for certain numbers, and they'll tell us what those numbers are very often. So like, let's look at these first few examples here. Evaluate the following expressions if, this is a very big part of the statement, x equals 7, y equals 3, and z equals 2. So I look at this problem and I plug in these numbers, or I substitute these numbers when I see that. So I get this first one. If I look at this right here, my first step is always just to fill in the numbers. We know that x is 7 because they told us right here. So replace the x with a 7 and replace the y with a 3 and the z with a 2. So just rewrite the problem with numbers now. And now I can see that really it's 7 plus the sum of 3 and 2. And if I go back to my order of operations, I know I should add first. Okay, so this is really going to be 7 plus 5. And when I solve it, what do I get? Yes, we get 12. So the second one, now they have z times x plus y minus z. Notice they've used z twice. So that means we're going to plug in this value twice. So let's go ahead and substitute first, rewrite this whole thing with the correct numbers. Z is 2, x is 7, y is 3, and z is 2 again. So if I just substitute, this is what I'd be looking at. Now I'm going to remind you, when you have a number right next to another number like z times x, or 2 and 7, it just means multiply. Okay, so this is really 14 plus 3 minus 2. And if I solve this next, well, 14 plus 3 is 17. So essentially it's 17 minus 2. And now I end up at 15. So just by substituting, we can kind of work through one step at a time. In our third example, y squared minus z squared, well, they told me y is 3 and z is 2. So this is really 3 squared minus 2 squared. And if you think about what 3 squared really is, that's a number times itself. So 3 times 3 minus 2 times 2. We know this is 9, and we know that's 4. So essentially 9 minus 4 is 5. Now notice some of the things I've done. I've substituted first just to rewrite the problem. And then I showed my steps one at a time down the page to get my answer. So what I want you to do now is I want you to go ahead and pause and do these last two here on your own. And when you're ready to check your work, come back to the video. All right, go ahead and check and see how you did. Notice, again, I substituted first, and then I solved them along the way to get 64 over here. And over here, there was a lot going on. We had z squared plus 9 times y minus 3 times x. So if you set that up first, then you can kind of work your steps through and you end up at 10. If you're not sure of a mistake you made, you might want to pause again and go back and double check. But we're going to move on to the next section now. All right, evaluating expressions is commonly used when substituting values into geometry formulas. We do this a lot. You'll see in these problems right here, they give you a formula. Area is equal to a side squared. We'll come back to that in a second. But if I think about where this goes, in geometry, there's a lot of things to know. The area of rectangles, of triangles, of circles, and prisms, and things like that. There is a whole bunch of formulas that we use to help us make sense of geometric shapes. And sometimes it's area, sometimes it's perimeter, sometimes it's circumference, sometimes it's volume. There's a whole bunch of stuff that we kind of learn over time. So when I look at geometry, there's a lot of shapes. There's a lot of formulas that help us understand those shapes. So if we go back to this one right here, they're basically giving you a square. Now we know that the area of a square is one of its sides times another of its sides. And if it's a square, if this is 5, that's also 5. So when they say the area of a square is a side times itself, that's how we figure out this first one. Okay, we know the area is side squared. So that's really, in this case, 5 squared. And we know 5 times itself is 25 square centimeters. So we're using a formula, and we're really just substituting a value here for the side length, and they gave us 5. What I want you to do now is go ahead and pause and do these next two on your own. Again, start with the formula, and then substitute, and then solve. All right, check your work right here. The area of this first one would be 11 times 11, which is 121. And it's the area of this square, so 121 square centimeters. And this one over here is 16 centimeters by 16 centimeters, so we can think of that as 16 squared. And that would be 256 square centimeters. All right, so there are shapes here for us to kind of work our way through. If I look at this first one, the top left, I'm going to do these two with you, and then you're going to do these two. So let's start right here. We know the formula, they gave it to you up here. For volume, it's length times width times height. And for area, it's base times height. So this is just a two-dimensional figure, so it's area. The area is going to be the base times the height. So fill that in, and the expression would then be where we substitute. Well, 6 times 2.7. And if we solve that, we would get 16.2 square centimeters. This is the area of this rectangle. And we can write it like this, or we can write it like this. They mean the same thing. If I look at the next box down here, the cereal box, they want the volume now because this is a three-dimensional shape. And the volume, well, that's length times width times height. So if I fill in the formula first, LWH, now if I substitute, I get the volume, the length is 9, the width is 3, and the height is 14.5. So that's where those came from. And if I multiply all three of those, I can get this answer right here, 391.5 cubic inches. Or we can write it like this, since it's volume, or since it's cubic inches, that's going to have an exponent of 3. So notice, area was a square unit of measure. Volume is a cubic unit of measure. Okay, now pause and do these two on your own. All right, check and see how you did. Here's what the first answer should have been. And remember, label it no naked numbers. And then same thing down here. Label that one as well. It was volume, so that's cubic inches. Again, no naked numbers. All right, so summary for this particular lesson right here. This is what you want to write down. When evaluating an expression, you simply replace the variable with the value or number. We call this substitution. We are just substituting the number in place of the variable. Remember to always follow the order of operations. We keep that in mind when we're solving expressions or when we're evaluating them. Now, if you need more time, go ahead and pause. But here is what your assignment is to go along with this one. Homework 3 basically has you evaluate these expressions. Notice they give you the values though. Evaluate this when x equals 8 and y equals 11. So you want to keep that in mind when you're solving these problems down here. But I want you to do the whole page, and let's talk about that next time we're together. All right, bye-bye.